Hello guys. So today this is going to be some kind of an unusual tutorial. It's going to be very quick. What I wanted to point out in this very short tutorial is how to create conditionals and loops in Grasshopper in terms of coding. So you know that Grasshopper is a visual scripting environment, so it's like basically coding with all that that means. So let's see how to create some loops like the usual for and while, and also how to create conditional statements like if, then, else in Grasshopper, which is very useful if you want to create some complex behavior in this inside this environment. So first of all, we need I'm going to create just one simple script in this case with all the three behaviors. I will start with a for, and then I will introduce a while, and then I will use an if then in order to switch between two different set of functions. Okay, so the way we create a for cycle is basically using a loop plugin. I normally prefer to work with Anemone, which has this loop start, loop end components. I just close the loop, and in this case, normally if you saw my previous tutorials, for example, on loops, I normally tend to use a single Boolean toggle determining both the trigger and exit for our loop. But this is not exactly correct because this true means that the loop is capable of starting because the trigger is set to true, and is basically forced to exit at the same time because exit is set to true as well. So I do recommend that you set this toggle to false in order to don't fire the loop, and use eventually a not logic gate in order to invert our logic value here from false to true and send this to exit. So when this is set to false, the loop doesn't start and exits at the same time. Okay, so this is probably a little more correct. And set the amount of repetitions with an 11 slider so that we can change how many iterations we will have inside our loop. Now, this is actually all you need to create a for condition. Okay, so you're basically defining how many iterations you want. So it's like defining how many, this number actually defines how many cycles, how many iterations you get from this loop. Okay, so the for is already set with this simple structure. The only thing you need is to implement a set of functions that work with this loop. I don't know, for example, let's take a point and use this point as the original geometry that we want to use inside our loop. And what I'm going to do as a function inside the loop, I'm going to move this point in horizontal x with 1 as a displacement factor. Okay, so what happens in this case is that this point is going to move to the right one step at a time, the step being 1, for as many iterations we have here. So when the cycle reaches number 11 of this for cycle, the loop exits automatically. Okay, but actually it doesn't exit because this value is still false, so there is no logic condition that tells this loop to exit. Okay, it exits, it stops because it reaches the maximum amount of iterations for the for cycle. Okay, so this is how you implement a for cycle. You just have this function here repeating one time after another by defined by this amount of repetitions. Okay, so this is the for cycle. Now what I want to do, I want to create a while cycle. So I'm going to basically copy paste all of this thing here, change it to while, like this. And the while, the difference between the while and for cycles is that basically the for ends when it reaches the amount of iterations that you have programmed with this slider, but while still goes on until a different condition happens that tells the loop to exit. So in this case, for example, I don't want to use the gate not in order to exit the loop. Okay, so I'm getting rid of this, and I want to create a new condition that forces the loop to exit. Okay, so this loop goes on and on while a particular situation is true. For example, let's say that we have, I don't know, like 50 iterations. Okay, and so this point with a standard for cycle moves until it reaches the 5th iteration. Okay, but what I want to do is in the moment we get to half the amount of iterations, I want something to happen that forces the loop to exit. So it can be whatever condition. So for example, we have here a displaced point, right? And the original point is here. So for example, I can calculate the distance between the original point and the actual version of the displaced point. Okay, and what I want to understand is if this distance, for example, is larger than a reference value, that can be 11, for example, then I want this loop to exit. What happens? What happens is that when the point is at its initial iterations, the distance between the original point and the point that's been displaced is smaller than 11. Okay, so this larger than will be equal to false. Okay, because the distance is not larger than 11. So if I send this to exit, the loop won't stop until the point that's been displaced reaches this distance from the original point. So if I fire this loop, you see that it stops at this point. And this means that we have reached the distance of 11 between the original point and the new point that's been displaced. Okay, so this is basically a while. It could be interpreted like while the distance between this point and the displaced point is smaller than 11, then move that point one step at a time toward the right. Okay, so this could be the while statement for this definition. Okay, let me arrange these things a little better. Okay, so now I'm going to group and turn this off. And the last one is going to be a conditional statement, so the famous if then. Okay, so I'm going to work with this definition here. What I want to happen in this case is not an exit of the loop, so I'm going to use an if then. Okay, so I don't want the loop to exit. What I want is to change the set of functions that happen when a particular condition is verified. So for example, using exactly this thing here, I can say, okay, so until the point reaches distance of 11, I want this point to move, I don't know, horizontally. Okay, and then once it reaches 11, then I want it to move vertically along the y direction. Okay, so what I need to do is basically implement two functions and then decide to use one or the other according to this value here. Okay, so larger than. So larger than is going to emit a false in the first 11 iteration and then a true in the remaining iterations, which will reach up to 50. Okay, how can we do this? Well, we also need to create a move function like this one. Let me get rid of the group, and I'm going to use the unit y vector. Okay, so what happens here is that the same point is being also displaced into the y direction. Okay, the point that comes from the loop itself. Okay, and what I want to do is that I want to move this point along the y direction only when this gets to true. So when we want to create any conditional statement, we must use a component that is located in the sets toolbar in the tree group, and it's called the stream filter. So the stream filter is actually capable of considering more statements, okay, but I'm only working with two, so stream 0, stream 1, and gate is simply the number 0 or 1, deciding which stream is being passed to the output of this component. So basically what I want to do is decide whether I'm going to use the x displacement, which is this one, or the y displacement, which is this one, according to this value. Now, gate asks for number 0 or number 1, and we have a true-false condition here. But you might know that, for example, the true-false condition is a logic value or Boolean value. So it means true-false means also on-off or 1-0 in binary code. Okay, so it's interesting, for example, to double check, but if I take an integer container here and take a panel and see what's the content of this container according to this true false, you see that when this is false, the integer is 0. When this is true, the integer gets to 1. So we can also use this larger than condition, which is basically a true false, pass it to an integer container, integer parameter, and it will become true, will become 1, and false will become 0. So this way we can decide which gate we are going to use, the 0 or 1. So in this moment, the integer is set to 1 because we have reached the distance of 11. Okay, and therefore the y displacement is being transferred to the S1 output. Okay, so if I use this configuration here as the output data, okay, then if I repeat this cycle, you see that it turns up. And of course, if I want this to go to reach the iteration number 50, I have to delete this cable here, because if I keep this cable active, whenever I reach this distance, the loop will exit. I don't want the loop to exit right now. I want to change the set of function that is going to use. So if I reset this, you see that the point from iteration 11 on changes its direction and goes vertically. Okay? In this case, for example, if I want to work with this conditional statement, it's better to recover our for condition. So if I set this to false, I have the loop stopped, and if I set it to true, the loop simply runs. Okay? And I can decide, for example, when this change in direction is going to happen. So I will use more iteration, and I will have a longer horizontal span and then vertical span. Okay, and with this, well, of course, I'm just here illustrating the way this conditional statement works. Of course, you can work with more interesting functions rather than simply displacing the point in two different directions. Yeah, but this is more than enough to understand how the conditional statement structure can be implemented in Grasshopper. So that's the third and last condition. And of course, I'm going to, this definition is going to be available in the description of the video. So just subscribe to the channel and stay tuned for more tutorial. Thank you guys. Bye.